Hello, hello everyone. Welcome to the session on Beyond Observability. I'm going to start sharing my screen right here. So, Sandeep Lewis, can you see my screen? No.
You can't.
Okay. There is a. Is this better?
I can see it.
You should.
Wonderful. Hello everyone. Welcome to this session on what's beyond observability and how to get there. I'm Shivnath Babu. I'm CTO and co-founder. My interests are in large data platforms, especially on the observability side. Observability and beyond it is definitely a key item of interest. In this session, I'm joined by industry veterans, Lewis from DBS. Lewis is the head of technology, infrastructure, and automation at DBS Bank in Singapore. And Sandeep Uttamchandani. Sandeep has been at IBM, VMware, Intuit, and is chief product officer at Unravel. And both of them, between them, experience, and they will share the stage with me today to talk about what's beyond observability. But first off, right, we have a raffle. This is the link that you can see on the slide. It's also in the chat. If you win, you get 1 month of coffee. And what do you have to do for that? You want to use this link. You have to comment on the LinkedIn post and cross your fingers. And of course, listen very attentively to what we are talking about. Post your questions. We'd love to keep this interactive, and we'll take some of the questions towards the end. So, as the theme of this entire data ops conference has been that everybody, every industry, every team, right, every enterprise customer or like the modern startup is trying to do great things with data, extract insights from data, build innovative products. And to do that, you need an app, right? It's the application that extracts value from data. Let's look at the journey of an app to set the stage for this entire session, right? So meet Linda. Linda is a data scientist at an enterprise company. She has an idea working with her teammates on how to extract some great insights from data, and she builds a data-driven dashboard in Python. So she shows it to her boss, Mary. Mary leads the product and she likes the dashboard. She says, "Hey, Linda, you're only using a week of data. Like, try to bring in a couple of months of data." So Linda then works on that. She brings, right, the good old Python program itself does not scale. So now there is a Spark application that's powering the dashboard. But then Mary says, this is excellent, this is useful. Now let's actually bring in more data sources. Let's connect this with multiple data sources, right? And of course, with that comes dependencies that have to be managed, as well as an orchestration that may have to be done to coordinate all of these data sources, right? And enter Airflow to manage all of these dependencies. So now we have Spark and Airflow. It's now become a very rich dashboard. It gets the attention of Rob, the CMO. And Rob says, "This is great, very useful. Can we make it real time?" Right? Fantastic. So to make it real time, enter Kafka, right? So now the data is being basically ingested and processed in a streaming fashion. But at that point, things have actually started to become like a little bit more complex. So Sam, the data engineer, comes and joins the team. He's working with Linda, and Sam brings some innovations like DBT to make this overall app and the pipeline easier and more agile. Well, along with that, because this is truly now gone production, Tony, the operations engineer, also joins. And Tony basically says, "Hey, this has now become mission critical. Let's actually start running it on the cloud, on a PaaS platform like a BigQuery or a Databricks or an EMR or Snowflake." Rob likes it. Rob says, "Great. Let's now start bring some machine learning to make these reports and the data actually learn and adapt." And the entire system that started with one app has now become a very rich pipeline, cutting across multiple systems and platforms, maybe even multiple clouds, right? With all the different components like orchestration, compute, auto scaling clusters, streaming like the platforms, dashboarding tools. And often we see that pipelines and data stacks are composed of from different systems, and they're all being tied together by the app, which may be the data pipeline. So it doesn't matter where you start, all roads lead to the same place, right? And naturally, with this comes complexity. So the entire platform is reasonably complex, as you can imagine, sometimes very complex. And with complexity, something could potentially go wrong. So what could go wrong? So complexity can bring four kinds of issues. It could be a performance issue, maybe SLAs are being missed, or it could simply be the agility of adding new capabilities, new features. And with lack of agility can come missed business opportunities. A third is the cost of this entire platform, this entire pipeline can actually get out of hand if not managed carefully. And last but not the least, the results generated by these complex apps and pipelines may not be correct, or may not be trustworthy or predictable. The solution that the industry has actually come with is observability, right? And what is observability? It stems from the fact that a system is said to be observable if, based on the outputs being emitted by the system, we can actually truly understand the internals of the system. That's the intuitive idea. Now, in the context of a data platform or a data pipeline, we can think of these outputs as the telemetry data. And very specifically, we can think as events the system may be emitting, or logs, right? The unstructured kind of logs, or metrics, or even traces of things actually happening through the system. Let's get back to where we started, right? We have this very important mission critical application and a team that is actually managing it. Let's say suddenly that application was slow. So Rob is not happy. The time, right? Let's say that, well, we have our logs, events, metrics, and traces, and that's what Linda and Sam and Tony are using to troubleshoot and understand what is going on. And they have to fix the problem, right? But which logs should I look at? Maybe Tony understands some logs. He didn't write the app. Linda wrote the app. Sam did some manipulation and some transformations on it. So it's very hard to figure and troubleshoot these things, and that's the reason why a lot of these issues can actually become S1 issues, and that can take many hours, sometimes weeks to actually troubleshoot and fix. So what is a better word? What could be better, right? Won't be great if instead of having to look at these events and logs and metrics and traces, right, something could have extracted from that data. Hey, here is your pipeline. There's an orchestration component. Here are the clusters where the Spark application is running. Maybe the clusters are transient and auto scaling, and they are processing this data, and this is the size of the data, and it's actually running on behalf of this key dashboard, right? So instead of looking at the kind of a raw data, uncorrelated data, you're looking at something that is semantically meaningful. Well, what could be even better, right? Maybe instead of having to look at all of these things, what if the system could actually tell you, hey, by the way, I've analyzed things. I'm seeing that in this entire chain of multiple components that are running, there is this one Spark application that is actually kind of starting to run into intense memory pressure. It's something that can actually now guide you towards what could be the cause of the problem by actually extracting patterns from data. Well, that's great. But what could be even better? What if? What if there was something that could actually tell you that, hey, by the way, that Spark application that's having a problem, it's just creating too many partitions, and that's causing the memory pressure because the data size has been steadily increasing, and it's actually across the tipping point. And if you cut down that number of partitions or tune your containers or whatever the case may be, that will actually fix the problem. That's great. But what could be even better? Right? What if that entire system and this pipeline, right, that's connecting multiple components could actually be self-healing, autonomous, right? doing end
Kind of like holy grail.
So this is what the theme of this session is, and what we have been like. A lot of us, Sandeep, Louis, and myself, we have been thinking about from the concept of like observability is great, but we have to go beyond it, because that is what customers and what this industry, like with all the need for mission critical applications and meeting SLAs and cost needs and agility are demanding. One way to kind of think of it is, well, uh, observability enables us to walk, but if you have to get from place A to place B, right, you could do better than walking. You could actually like skate or run, right? You could like ride a horse, right? Or you could actually drive a car, or like why not have a self-driving car that can actually get you there. So with that theme, I would like to hand over to Louis. Louis has actually been driving a whole bunch of these cognitive capabilities from the telemetry data at DBS. Louis, please take it away.
Um, Thank you, and thanks everybody for attending the session today. So I'm going to walk you over the next 9 to 10 minutes through what we've been working on, and rightfully so, as it was mentioned earlier in the session. Um, we came to a point where observability really doesn't cut it, right? When you are on an always on environment where your DG banking applications are fully needed, you come to a point where your NCI, which stands for negative customer impact, truly becomes a key valuable indicator on how your systems are relating. Now, when you have a shop where you have a combination of proprietary software and legacy, the fact is all of these systems are collecting logs in many different ways. Like it was mentioned, Spark can be one of them. If it's vanilla Spark open source, if you're running Spark on Kubernetes, if you're running a Cloudera cluster, and the list goes on of the different tools that are out there. So we focused our efforts with instead of focusing on the tools that are already developed by third-party vendors across the board, can we build a hierarchy brain on top that can collect and understand the metrics from the diversity of tools that all the environments have, without having to forcibly force the organization to rip and replace for something new, which ends up being an endless project. It will never happen. So when we look at root cause analysis, what happens after the fact, how do you improve the RCA? How do you improve productivity, by providing less noise, toil reduction, proactive, predictive alerting on emerging issues, towards you controlling the different error budgets that are factored in for each application. And then, of course, performance and capacity analytics are key contributing factors of, what happens when a change is induced, whether it's deprecating performance and different things like that. Ultimately, we're talking about improving time to recover. And now we're up to a point where in a containerized world, your containers should be able, if they're non-persistent containers, then they should be able to recover in a matter of seconds. Ultimately, it's about NCI, better end user experience. We're no longer in a game of measuring systems for IT to be able to monitor. We're measuring systems with the intent to provide a better end user experience and customer experience. So if you go to the next slide, I'll give you some hints and tricks of what we're doing, how we're doing it today at our bank, and for particularly for the DBS data platform. So if you go next, Babu, next slide. I think Babu froze. Okay, so I'll continue as we go. So the whole concept of what we're doing is, imagine yourselves having, the source, right? When you have the source, all the different tools you can have: servers, middleware, AV, IAM tools, and then you have applications that are collecting different telemetry. It could be through different systems or different log collectors. It could be node exporters. It could be metric beats, file beats. You can have an ELK stack. But ultimately, what you want to do is you want to create an open platform that you can ingest all this data to. For that, basically, you require three major elements. You require a historical repository where you can collect and cross-check data. That's one. You need a real-time series database, which it's essential because time becomes the metadata de facto to identify a critical incident and identify the correlations. And third, you need a log aggregator. It could be an Elastic Stack, it could be any Ray Logger, Logstash, you name it. But ultimately you need something that can collect logs. How do you define the ingestion is one of the things that I get asked consistently. You got to do it all based on metadata. If you can clearly define the metadata and how the data is ingested to the hierarchy in 3 DBs that I mentioned, right? When you build your AI and ML algorithms to start understanding and analyzing and recommending. So I want to call it cognitive, and I'm not going to call it AI because we actually have machine learning, a whole bunch of machine learning inside. And that ML, as you know, it's just a ramification of the entire AI. The majority of the elements that you run for prediction that we're running today are predominantly supervised training models, because most of the data, it's already well understood. Our unsupervised models are more to try to identify metadata correlations that we didn't understood before, and now we know they exist. Ultimately, what our system does is basically it provides a recommendation to our site reliability engineers, and it gives them a list of elements of saying, I have identified this set of errors or incidents that have happened over the last month that have been repetitive and continuous. And then our site reliability engineers need to marry that with our automatas, right? Which is our automation engine. You build the right scripting, the right automation to proper fix and remediate, so that every time the incident is identified, it basically maps incident A has an automata B equals C, right? Basically, if we find A, then B, and then you have an output. So what we've been discussing before the deck was shown is we talked about the data sources. We talk about how we ingest and curate, being fully metadata driven. We define the metadata before it actually gets ingested. And then we actually park that into the ADA or ADI data lakes that you see there. On top of that, we provide an analytical engine, which is what we were talking about, how we build our ML for SRE automation, SRE auto loops, data movement service, incident prevention, application tracing. Now, I want to say the key when we use tools like Unravel and such, which is the next slide, is because the telemetry of event data correlation, it's already there. I don't need to worry about marrying the correlation of it, right? I can just consume the data of a correlated tool. In the event of big data and analytics, Unravel plays a huge play with us, right? Doing Spark, doing Presto, doing Hadoop clustering, Yarn, Zookeepers, and just the list goes on. And then of course you're going to have infrastructure tools that that play a unique element. Most of the companies are using Prometheus today, so that's that's normal, right? You got to consume node exporters, metric beats, file beats, etc. So ultimately what we have is we have observability with Grafana, Kibana dashboards, but really what's on those dashboards is more recommendation output from our ML engine. It's consistently recommending us what to trigger, what to execute. That on the right hand side, which is called DARE, right? Or DARE, basically is an automated remediation engine, and that triggers the automated executions to our entire infra. So if we go to the next slide, and I'll wrap it up there with what we're doing, is ultimately what we've done is we have a view here that I provide. Everything that it's orange is basically batch ingestion. Take systems that are batch oriented, and everything that it's in the light green color is near real time, flowing through a real time series DB. So in the end, all we're doing is we're not changing the tools. We're collecting the metrics from all of the tools, including the tracing tools. We are providing a hierarchy mapping of the data being collected across all the tools in our environment, mapping them through metadata, and leveraging that to provide the right ML. And the majority, again, it's supervised models. We do have unsupervised to find the relationships or the hidden see, and extract out of that the proper recommendations for triggering our self-healing capabilities. So with that, I'll pass the mic to Sandeep, and thanks a lot for hearing me out today.
Fantastic. Srimad, if you can please continue bringing up the slides. So we have about 5 minutes or so, and the context here, just continuing the theme that Shivnath and Lewis are talking about. When you think about observability, it's more of going from the raw data, the telemetry data, to insights. Now, beyond observability, as Shivnath was mentioning, how do we go towards more of that self-driving, self-healing? It's really thinking broadly in terms of how do you convert those insights into impact. And this is where, I'm going to talk about this pattern, democratizing the data platform with governance. So very quickly, modern data stack, it allows your teams to go really fast. It's making data accessible, AI accessible. Everyone is speeding through. That's exactly what you wanted. It's a freeway for your data users. But guess what? When you think about if these freeways are not governed, they will clog with missed SLAs, poorly written queries, out of control budget, and several things that, in fact, Lewis was mentioning as well, things we are hearing across through the other talks during the day as well. In fact, even going further, if you don't take care of these clogs, going to the next slide, these clogs can lead to pileups on your freeway, missed project deadlines in several shapes and form. Now, how do organizations deal with these clogs and pileups? There are basically two extremes of operating your data platform, and having worked with multiple customers and my own experience, you often see on one extreme strict control. Everything goes through a checker, Jira's, incident management. The other extreme is the wild west. Run what you want, pretty much make sense of things yourself. And really neither extreme actually is good. So what what we really wanted to talk about as we think about the aspect of observability towards impact is the best of both worlds. How do you democratize with governance? How do you get everyone driving on the freeway without the clogs and without what you would think of as the pileups? So there are 5 patterns that we've actually learned working across the best of the best, both in our customers, broadly in the industry, and based on my own experience. And in fact, several of these are visible in Lewis's description as well. So I'm just going to quickly walk through each of them and actually just show you visuals. So if you go to the next slide, right, um, as you think about democratize with governance, there are certain patterns you need to establish to build really rock solid data ops. The first pattern, which is something you can build using open source, using tools, you can building blocks like Unravel, is the wall of spenders. Provide visibility, who's using how much, what does it cost? I have an example where one of the data scientists on my team was running a query over the weekend that cost us $40,000. Nobody understood or nobody knew, right, that that was the spend. So having this wall of spenders is one pattern that provides that natural, I would say, control in terms of how things are managed. The next piece, again, in this interest of run your stuff, but then at the same time have proactive alerting. There will be rogue jobs, there will be orphaned processes, there will be things which can just break the bank, impact performance, clog your database, so on and so forth. Another very important piece in your in managing these data freeways. The third pattern, and again, this is something that is becoming more and more common, is you want your data teams to run jobs in production, but as a part of the promotion, make sure that you know if these jobs have inefficiencies. Some of these jobs are not well written. In fact, there's a common understanding that the data scientists and domain experts may not be the best engineers. So have this governance of having an optimization score before promoting anything in production. So just going to the next slide, there's this aspect of being upfront where the inefficiencies are when you think about job optimization score for promotion, which is a very important pattern. In fact, I know DBS applies that in terms of making sure before you get things in production. The fourth thing here to bring up, and I'm going rapid fast given the time, is really the picking of the schedule. Like oftentimes you want to enable your data users to pick a schedule, but then give them the heat map schedule or heat map dashboard. If you just build up the slide, show or have that visibility of what parts are things where maximum number of queries are running to avoid resource contentions. And again, this resource contentions are applicable even in a serverless world where you're using more of the slots or predefined allocations, reserved instances to make sure that you get the best pricing. The last pattern, or in fact, the second last pattern here, is enabling your teams as they run forward with their jobs, giving them the trends and visibility on the SLAs. Oftentimes, it's a guesswork. As a data scientist, you may actually not know if your pipeline is completing. And again, this is not just from a performance standpoint, performance, cost, quality, one place where they can see it all. Very important as a part of the democratization journey. And the last bit here, before we completely run out of time, is allow assessment of migration. Not all jobs are, I would say, need to be done in a lift and shift fashion. So before you move into the cloud, there are some jobs that need to be optimized, making it easy for teams to actually make that assessment. And again, while you're democratizing, allowing people to run things in the cloud, you're also kind of doing a gatekeeping and making it more self-serve. So to wrap, what I just went through is really this combination of how you democratize with governance, and wanted to share a few patterns which you can apply. And again, these are patterns you build using your in-house tools as well as open source. That is pretty much it. Just wanted to wrap up with the plug. From an Unravel standpoint, we are rapidly growing. Both in terms of hiring as well as we have a free trial to try it out. with that, back to you, Shivnath.
Thank you, Sandeep and Louis, and apologize for the glitch that happened when Louis was presenting us very
Did we lose Shivnath? Looks like we are out of time over here. Let's quickly look at the questions in the chat. Yeah, I think probably I don't see any questions here. Louis, can you hear me?
Yep, can.